Hi guys, we're gonna give it a minute, see if other people need to arrive. How are you guys doing today? All right, so what I'd like to do is we're going to wrap up chapter 1.7 today in terms of topics, and then we'll start working on the chapter 1.7 classwork pages. Depending on how things go with time, I want to finish up the topics. We'll have today to work on the classwork, and then we'll also have Monday to work on the classwork as well. If you guys get a chance to take a look online on our Canvas page for next week, we have an exam schedule. This is all of chapter 1. What we're going to do is Wednesday's class next week will be a review class where you guys will get a chance to ask questions. You can ask questions on the homework. You can ask questions, let me just a second. You can ask questions on the problem set. Don't forget that there is a problem set due next week, next Thursday. So let me write this down. What's due? So what is due? So coming up next week, we've got a lot of stuff that's happening. Right, we're finishing up this week. We finished chapter 1.7, and so next week you'll have classwork. So all this stuff will be due. I'll take the classwork. I'll take it on Monday. I'll be flexible about it. You know, from some Monday's classwork, I'll take chapter 1.5, 1.6. I think you already passed in 1.3, 1.4. If you haven't, you can also pass those in, and then let me know so I can go back and check those for you. On Monday, I'll check chapter 1.5, and I'll take 1.6 as well. On Thursday, I'll take chapter 1.7 for classwork. Okay. Also, homework. We have on Thursday, right? I'll take the homework for chapter 1.5, 1.6, and 1.7, which is basically questions 12, or is it maybe question 13 until the end, right? So this is the rest of the chapter because you would have passed in 1.3 and 1.4 already, okay? If you didn't pass those in already, I'll take those again. You can certainly pass those in. If you're submitting those onto the old assignment for 1.3, 1.4, make sure you email me so that I can get a feeling for, like, you know, who's doing what, so I can go back and grade them. Otherwise, I won't know to check. So homework is there. We also have a problem set. The problem sets are listed at the very beginning. I'll post the problem set again. I think it's posted again in terms of next week's assignments, but I'll check again. I think, I can't remember how I have those assignments set up, but I'll set that assignment due. It's due next Thursday. That's problem set number 1. Oops, I can spell. That'll be due. So that whole thing is due. This problem set, it's a set of, and you can certainly talk to other people about this if you want. And then you can certainly ask me questions, you know, in office hours, we can go over it, things like that. It's to get you to think a little bit more in depth about things, and you don't have the solutions for it like you do for the homework problems. And it's not something that I go over in class necessarily, but you can certainly ask me questions about it. But that's due on Thursday. We have problem set number 1. And then on Thursday, we have our first midterm exam. This is all of chapter 1, all of it. And this is on Thursday. So there's a lot of stuff coming due next week. So this is next week. There's a lot happening. Okay, there's a lot of stuff kind of coming into fore. I tried to take the classwork on Monday so that you're not kind of getting this avalanche of things that are all coming due on Thursday. So don't forget, Monday I'll take classwork for 1.5, 1.6. Thursday I'll take the classwork for 1.7, which we'll start going over today. The homework for the rest of the chapter is due on Thursday. That's when we take our exam. So it'll be Thursday. All these things are due at midnight. Problem sets due Thursday at midnight. And then the exam, we'll have an availability window like we do with our quizzes. That'll be an availability window starting on a Thursday and then going until Friday. And then the exam, you'll have an hour on the exam instead of a half hour like you do with the midterm. I mean with the quizzes. So keep that in mind. There's a lot of stuff coming up. I can put up an announcement for this later so that you guys can be reminded about things that are due. Okay, so a lot of stuff coming due. All right, so let's finish off our topics on chapter 1.7, and then we'll start working on classwork for 1.7. Remember, Monday, what's going to happen is, so let me just write down what to expect. So today, we have class on Thursday. You know, let's talk about that, and it's a great question. Give me just a second to answer things, and we'll talk about what you guys want to do. So today, we're going to finish the topic for 1.7, and then we'll start our classwork. I think we did one of the problems before, but we're going to keep working on the classwork. On Monday, we'll work on classwork for chapter 1.7. It's such a big chapter, and there's so many things that we'll just basically spend all class on Monday doing classwork for 1.7. Wednesday will be an exam review. So what you'll want to do is look at your Canvas page. You know, for next week, we have the exam listed for next week. Look for exam review materials. I'll post those later today at the latest by tomorrow morning so that you guys can get that. So look for exam review materials. I'll create a whole place for it. Exam review materials for next Wednesday. We'll go over those and any other questions that you want to ask. It's basically kind of a free form class on Wednesday. And then on Thursday, we can do one of two things. If you guys want to have class on Thursday, we can certainly have class. I guess I was sort of thinking that, you know, you could use that time to study because you're taking the exam. The exam availability window starts outside of class to accommodate our different time zones. And so because of that, I don't necessarily have to have class on Thursday so that you guys can just use that as a review period. Tell me what you would like. You can tell me in the chat. You can do it privately or to everybody else. Typically in other classes when I've had exams, I have not had class. No class because the exam. But in those classes, sometimes the exam actually started, the availability window started when the class started. But our class starts at 10:30 instead of at noon. But I wasn't gonna necessarily have class because we had the exam. Excuse me. Now my allergies are going crazy. What would you guys like? It wasn't necessarily going to have class because we're going to have the exam. Is that okay with everyone? Flexible. Yeah, it's okay. It's okay if we do not have class. Okay. All right. It's okay if we don't have class. Okay. All right, great. If you guys have any issues, you want to email me about it privately, that's fine. We can talk about it. So let's plan next Thursday, a week from today. We won't have class, but you guys will be having the exam. Okay, so we'll accommodate your shift in schedule that way. Because we're taking, there'll still be office hours on Thursday, that's right. Although if you've started the exam, technically you shouldn't come to office hours because you can email me if you have a question you need clarification for on the exam, like what are you really asking for? Is this a typo or whatever? But if you've started the exam on, you can't come to office hours and ask me about it. So just keep that in mind. So yes, I will have office hours on Thursday next week, but don't come to office hours asking for help if you've already started the exam, okay? So keep that in mind. All right, so I'll put up this announcement later just so that we can be on that page. All right, you guys, so let's go ahead and finish our topics for chapter 1.7, and then we will start the classwork. All righty, very exciting. 1.7, part 3. Okay, so this is about reflections. Reflections are super important, right? So like, you know, like why do we care about reflections? So we've got our computer screen, right? And we've got things that are happening on our game. So say I launch a ball and it hits the bottom of the screen. Well, do I want it to just go off the page and disappear, or do I want it to like bounce, right? If I want to launch something and I want to hit an object, say like, you know, I'm playing Pong and I want to hit that and I want it to bounce. Do I want it to bounce, what do I want it to do? So if you want to make it look realistic, we want to have reflections, right? Because reflections are going to make our game look realistic. Reflections get used a lot in games, and in how we visualize things when we actually put things up on the screen. So, and often we reflect off the side of the screen, or we reflect off objects that we have programmed into our game. So let's talk about how we actually do the math behind the reflections so that it looks real, right? It looks like, so when people watch the game, they don't go, oh, that looks strange. It's not quite functioning like I expected to because physics isn't happening. Or you can tweak it in a consistent manner, okay, so that your game world has consistent laws, right, that you follow. So let's learn the math behind it. So let's take a step back. Think about big picture. So I have some kind of a surface here, right? And I have an incoming, this is coming in and it's gonna hit, right? So I've got something that's incoming. Let's write down what we have. So this is an incoming, or what we call an incident. It's a line. It's our object, but it's following the trajectory of some line. We're gonna make it a straight line. So our object is following this trajectory of a straight line, right? And then it hits here. This is our point of intersection, our point of reflection. We're gonna find that it actually follows the same laws as intersection, only slightly different. So now it hits that and then it reflects off. So this is our reflected line. Okay, so there are a couple things that happen. Let's draw these pictures out. So let's think about our surface. Right at this point, we've got a normal. Our normal to our surface, and it happens, our normal to our surface happens at the point of reflection, right? And then what we want to do is we want to think about, let's call this incoming line. This is my V, and I'm going to call my reflected line W, just for variable's sake, right? So now what I want to think about is I've got this incoming line, and I've got this normal to the surface. I'm going to take this incoming line, and I'm going to project it. This is my projection of my incoming line onto my normal. I'm going to use that to do stuff. I need the projection in order. This is why I said projections are really important. I'm going to use that to help me. Okay. Also, something I want you to think about too is that the angle, right? The angle coming in is the same as the angle going out. My incident line angle is the same as my reflected line angle. It's an important concept. Okay. We're going to talk about how we all figure this out as we go. This is our normal. This is our projection. This here is what we call, remember this one was our orthogonal to the projection. So this is our orthogonal. Projection, and that's just our projection, right? Remember how we calculated these out. So this is going to be like the incoming minus the projection gives us the orthogonal. All right, so let's start looking at our math. So we can call this the incoming line, incoming angle, and the reflected angle.
This type of reflection, this is only like for like a ball or something that hit a wall that's coming back at you, right? It's not like a mirror reflection.
Yeah, it's like a mirror reflection. This is like physics. Yeah.
Oh,
this is like a reflection off of any surface. They follow the same rules.
Okay.
You're thinking of like like if I want if I'm thinking about this correctly, you're thinking I've got a shape like a face and I have a mirror and I want to reflect that. You know, I want to reflect that in the mirror. Is that what you're thinking, like a shape?
Yeah.
We're going to use this idea of reflections when we do chapter 2, and we start thinking about if I've got like the surface and I want to reflect it across a plane or across a line. So what's happening here, I think if I'm understanding your question is, I have some object coming in, it hits the surface and it bounces off. This is the math reflection, but we're going to use the same topic in chapter 2 when I take an object and I want to reflect it across a line or a plane. And that's important because, like you say, for an image in a mirror, I need to have that image be transposed correctly, right? And it has to have the same properties, or it has to be mirror reflected depending. And then and the distance that it goes has to be correct. So we're going to talk about that in chapter 2. This is, you're right, this is like a ball or something bouncing off of some kind of a surface.
Yeah, the obtuse line is more like a ball. The normal surface seems like it would be a mirror.
Right, so the normal surface is just something, this is a mathematical construct that I've created, right? So this is my surface, this is the orthogonal vector to that surface, right? And this is the projection of the incoming line onto that orthogonal. This is real, this is real. I've got this ball coming in, boing, it bounces like that, okay? Mathematically speaking, I look at the angles, I could look at the normal, I can look at the orthogonal, I can look at the projection. Those are all things that I can extract out of that, but mathematically speaking, I've got a ball, and I've got a ball that's bounced off. Does that make sense?
Yeah.
Okay, great. All right, so let's go ahead and think about how we're going to figure out the math on this, right? So our goal is to find the equation of the reflected line, right? I've got an incoming line, I'm given this, right? Or I can derive this line right here. I want to get the equation of this line because it's going to give me the trajectory where I need to paint my object as it bounces off the surface, right? So I'm going to call it L of t equals b plus t w, right? So w is my reflected vector, right? And then, so let's write down, so w is my direction of the reflected line. That's my reflected vector. Direction.
Does it matter the speed that the object's hitting the reflection?
I love it how you're asking me questions that lead right into topics that we're going to cover in class. So speed, the velocity, is something we're going to cover in chapter 3. That's where we get in,
okay.
when we get into calculus topics. So that's something that you can tweak, right? So your world, right, that you're creating will have a certain level of gravity, right? That you're going to define. My gravity in this world is, it's the same as Earth, or it's lighter than Earth, or it's, you know, heavier than Earth, whatever. You're going to define that law of physics. And then how we derive velocity and position from our gravity, that's just physics. That doesn't change with regard to the world. But the gravity level, that'll change depending on how you want to define your world. So then if you want to add an acceleration component or a velocity component or whatever, right, you can do that. But we're going to learn that in chapter 3.
Okay.
Okay, great. So hold your horses. These are great questions.
Sorry.
Right into topics that we're going to cover. Okay. All right. So this is the direction of our reflected line, right? And B, right here, this is B. This is the point where the line is reflected. It's like an intersection point, but instead of intersecting and going through, it's bouncing off. Okay, so that's what's happening here. Okay, so the thing that we're going to need, we're going to need some stuff. So we know now how to find the intersection of the incident line. That's our incoming line, our incident line, and our plane. That's our surface, right? This is our surface. Incoming in our surface, right? This, we know how to find that intersection point. This is going to give us the point of intersection. We've called B. Right? I put a little arrow over it because maybe it's XYZ component or X and Y component. It's not really a vector, it's just a multi-component point. All right. 2, what we know is we have to get the direction of the reflected line. We have to break the incident line into 2 orthogonal parts. Okay, the first part is projection along the normal vector, right? So that's that's this green line right here, right? So this is the projection of our incoming line V onto our normal. That's what we need. The other part is the perpendicular to our projection. This was equal to what we called Q. That was the orthogonal to our projection. Once we find the projection, I can find the orthogonal. It's just a straight vector addition. We did this before. We'll do it again in our examples. So let's draw a picture, and we'll break it down into pieces, and then we'll work through a couple examples. You guys all have this. Okay. So let's remember our projection stuff, and in terms of our incoming. I'm going to redraw this. So this is our surface, right? Here's our incoming vector. I'll call it V now. Okay. Here's our point of intersection, right? Then here's my normal to the surface, to the plane. Okay, and then here's my outgoing. Draw that in light color for now, because I haven't figured it out yet. Okay, so the first thing I'm going to do is, this is my incoming. This is going to be here. This is my orthogonal, right? That's my orthogonal to the projection. This here, I'm going to draw this bolder colors. This is our projection of V onto N. We're going to need all these to calculate out my reflected line. Okay. So this is incoming. We call it incident in physics, and this is our reflected. Okay. That normal there. Okay, so now let's remember our projection formula. So our projection of V onto N looks like this. V dot product with N over N dot product N times N. It's a scalar multiple of our normal vector. Our orthogonal, that projection, right, is the incoming minus our projection. This is just vector math, right? So the orthogonal plus the projection gives you my incoming, right? Orthogonal plus projection gives you my incoming by vector math. Okay. So now I can do some algebra here. So my W is going to equal to just like I'm rearranging here, my W is going to equal to my orthogonal minus my projection. So you can imagine I've got my orthogonal here by my parallelogram rule, my orthogonal is there. So when I add up, right, these two, right, I'm going to get this. But because it's like basically being subtracted, I subtract these two, I get that. Okay. So in terms of our vector addition, remember all the stuff that we did like on our first day, how we did all the vector addition. Yeah.
I'm sorry. Is that a projection of N to V, or is that U to V? I'm sorry.
Yeah, so there's no U.
Okay.
This is my handwriting. The U has a little hook on it, right?
Yeah,
and V
okay.
is just a sharp line. Yeah, I know
So
my
it's an
handwriting
N.
is yeah, and then that's an N. So I'm projecting V onto my N. So I get this projection of V onto N. Here's our projection. Here's our N. Here's our projection. It's like it's a scalar multiple of our normal. I'm projecting my V onto that normal. Okay. So now here I'm going to substitute in V minus the projection. Right. So now I get W equals V minus projection of V minus the projection onto V. So my reflected vector is equal to my incoming minus 2 times, oops, the projection. Super important. Put a couple stars on that one. Okay, so now we have a point, right, which is our intersection point, that's B, and a vector parallel to the line. This is our reflected line. Guess what? I'm done with making And I have all the pieces I need to make the equation of the line that's being reflected. So right, so my equation of the reflected line is going to be x equals b plus t times w. B I found when I did the intersection of my incoming line with my surface, right? And then W I found by saying incoming minus 2 times the projection of V onto N. This is an N, it doesn't look good. Okay, we're gonna go through some examples so you can see what this looks like. So example 10. So example 10 says, on my example sheet, excuse me, example 10 says, given the line, it hits this plane. What's the equation of the reflected line? So I'm just gonna draw this quick thing here. So I've got this incoming line, hits the plane, and then it reflects off. This is my L of t, this is my plane, and this is my reflected line. I'll call it R of t. Okay, I guess technically I should use a different parameter, S. Okay, so now, what's the angle of reflection? So we'll take these piece by piece. Okay, so now let's break up our line, so our incoming line. I'm going to rewrite this. I like it as a vector equation. So I'm going to write this x equals, right? This is going to be, my point is going to be 0, 0, 1 plus t times my vector. My coefficients are 1, minus 1, and 1. Okay, so that's my incoming line. This is my incoming line right here, and I just rewrote it because I like it in this form better. Okay, and it hits the plane given by x plus y minus 2z equals 4. Okay. So for here, I'm going to yank out the normal to my plane. This is my surface that I'm reflecting off of. Normal to my plane is coefficients of x, y, and z, 1, 1, minus 2. Okay, so I need to find the reflected line. All right, so I need to do a couple things, right? I'm going to have to find the, so I've got the normal, here's my normal. Here, I need to find the point of reflection, point of intersection, and then I have to find my projection. All right, so let's do it. So the first part is our point of intersection of the line in the plane. Okay, we've been doing this, so we know what to do, right? So we take our line and we break it down into component pieces. X equals 0 plus 1 times t. Y equals 0 minus 1 times t. Z equals 1 plus 1 times t. It's like you can see it. It's from that equation that we were given here. All I did was rewrite it in terms of components. I have to plug that into my plane equation. X plus y minus 2z equals 4. Wherever I see an x, I plug in a t. Plus y minus t. Minus 2 times z, 1 plus t equals 4. And now I combine like terms and I solve for t. So I'm going to go t minus 2 minus 2t equals 4. These t's cancel. I get minus 2t. So I'm going to add 2. So I'm going to get minus 2t equals 6, divide by minus 2, so t equals minus 3. All right, so we just found out that the line does intersect the plane, because if it doesn't intersect, it's not going to reflect, right? So it does intersect the plane. Now we need to find the point of intersection. So I'm going to find the point of intersection by plugging this t into my x, y, and z equations here. So x equals minus 3, y equals minus a minus 3, z equals 1 plus minus 3. So my x coordinate is minus 3, my y minus minus is plus 3. So 1 minus 3 is minus 2. So the point of intersection is minus 3, positive 3, minus 2. Okay. That's stuff that we did earlier this week in terms of chapter 1.7, which is intersections of a line in a plane. Okay, so now it's not intersecting, it's reflecting. So we got to find all that. We have to find the vector of reflection so that then we can make an equation for the line. Okay, so part 1. Part 2 is we have to find the projection. Find the projection of V onto N. All right, so we said that was V dot N all over N dot N times N. Let's plug in the blanks, right? So V, my incoming vector, right? My incoming vector right here, this is my V. 1, minus 1, 1. That's on my line. So my V, so that's equal to 1, minus 1, 1, dot. My normal, we got from our plane right here. Okay. So 1, 1, minus 2. And then I have to do normal dot normal. Dot 1, 1, minus 2, and then multiply it by my normal. That. Okay. Go ahead and start working through the math. So my projection. Okay, so that's going to look like 1 minus 1 minus 2 all over, so it'll be 1 minus 2, right? So 1 plus 1 plus 4, okay? So this is going to equal to minus 1/3 all over 1, 1, minus 2, which is equal to, I'm going to distribute the minus 1/3, so minus 1/3, minus 1/3, and then this is positive 2/3. So that's my projection. So now my next step is I have to find my reflected vector, which is my incoming minus 2 times the projection. Right, so my W equals my incoming vector, 1, minus 1, 1, minus 2 times my projection, minus 1/3, minus 1/3, positive 2/3. I'm going to distribute this. I'm going to make it a positive. So I'm going to go plus, this is going to be minus 2 times minus 1/3 becomes positive 2/3. Minus 2 times minus 1/3 becomes positive 2/3. Minus 2 times positive 2 becomes minus 4/3. So now I get to add component to component. 1 plus 2/3 minus 1 plus 2/3, 1 minus 4/3 to give me 5/3 minus 1/3 minus 1/3, and that equals my W. Now I have the point of intersection, and I have my vector. Now I can put these together to form a line. Right, so I'm going to use my vector equation. This is going to be x bar equals x naught plus, we'll call it S times W. S for a different parameter because T we used on our incoming. This is going to be x bar equals my point of intersection, minus 3, 3, minus 2, plus my parameter, S, times my reflected vector, 5/3, minus 1/3, minus 1/3. Now, because this isn't a full line, right? A full line is, infinite. My parameter, is all numbers, right? Because this is only the positive aspect of that. I have to restrict my parameter to be only positive numbers or 0. And that is what makes it a reflected line. And that's because the line comes in, it bounces off. The line doesn't come in and keep going. It doesn't intersect and then pass through the plane, right? It hits the plane at that point of intersection, but then it bounces off. So this line here, that it's our reflected line, is only the positive aspect. Okay.
Would you say the S represents?
It's our parameter. I could have used T, but I had already used T in my line equation, right? So in my line equation, I already used T. So I decided I would use a different parameter.
Okay.
so that the two lines aren't tied together, I can, you know, they're now independent lines.
All right. Thanks.
Yeah. All right. Phew. I'll give you guys a second to finish writing that down. And then we'll do the second question, which was, what's the angle of reflection? Means I have to find the angle of incidence. Once I find the angle of incidence, then I can find the angle of reflection. I'll give you guys a second. Okay, you all set with this page here? I'll scan this in later so you have the rest of it. Right. Okay, so part B, angle of reflection. Always good to know. All right, so remember that the angle that's incoming equals the angle that's reflected. So I'm going to find my incoming angle because that's what I know. So I'm going to think about the cosine of my incoming angle equals right? This is my dot product, right? So remember, let's remember what's happening. So I've got my surface. I've got my incoming vector. This is V, right? And I've got my normal. These are the things that I know. Here's my normal. So what I'm going to do first, I'm going to call this theta. I'll call this, give it. This is my theta. So now I know the vector that's incoming and I know my normal, normal to the plane, right? So if I find out this angle here, then what will happen is, here's my reflected line, here's W, here's theta. Now what we really want is, we tend to really want this angle because we want the angle with the plane, because that's the part that we visualize. And then this is the angle that's reflected. These are equal. Okay. But what I know coming in is the angle with my normal, my vector and my normal. So I have to find that angle first, subtract it from 90 will give you my incident angle. So let's do this. So this, I'm going to figure out this. So this is the definition of my dot product. Remember, the dot product of two vectors equals the magnitudes times the cosine of the angle between them. So I can find the angle between them by manipulating their dot product. So the magnitude of V, I calculated it offline. Magnitude of N, I calculated it offline, right? And then this is equal to the cosine of theta, okay? So to calculate actually what theta is, I'm going to go theta equals my inverse cosine. It's on my calculator. It's an inverse button. This is a dot product. But you're going to get some number, right? So when I do this, I'm going to get this theta equals 118.2. Okay, it's okay that it's if this is greater than 90, then what that means is that we're actually, you know, I'm coming in from here. It's just like the way that it's being represented. So what I'm going to do is I'm going to subtract this from 180. Actually, wait, I'm wrong. Let me do this. Let's subtract this. We'll take the magnitude of this difference. 90 degrees minus 118.12. Right, so this, I take that, this is 90, this is my normal, and this is my incoming. And what I'm going to do is I'm going to take the magnitude because I want the angle to be positive. Then I get 28.12. So that gives me, this is my theta sub I. This is the angle with the plane. Okay, which is also equal to my reflected angle. Oops. With respect to the plane. Okay. Phew. It's a lot of stuff. But we're gonna I'm gonna start working on the classwork in just a second, and then I'm gonna we're going to work on the classwork again on Monday. So don't feel like, oh, we have to get all the classwork done today. Okay. You guys look good with this part here? I know it's a lot to take in. I'm going to post these. I'll scan that in and post that later. Okay, so I'm going back to classwork for 1.7. I'm looking at, this is, it's listed as part 1 classwork, right, on our website. So I'm just going to start, working through problems. We did this one, I think, earlier this week. So I'm going to just keep working through. You guys you're welcome to work on it. I encourage you to work on your classwork now, or you can work on your homework. I'm just going to be working through these problems here for the next, 15, 20 minutes or so. And you can stop me and ask me questions on stuff. I goofed up. Oh, I'm sorry. Oh, that's right. Okay, good. You know, this one's more complex. I'll kind of come back to this one. This one's probably more complex than you'll see because it's a three-dimensional line. So it's harder to think about, but I'll come back to that one later. It's all being recorded too, so you guys can check these solutions in the recording later. Hey guys, I'm gonna stop here for today. On Monday, I'm gonna pick up. Okay, and I'll keep working through classwork problems for 1.7. Also, if we have time on Monday, I'll answer questions for homework problems or other things. Take a look later today or tomorrow, and on our Canvas page for exam review materials. Okay, I'll post an announcement with all the stuff that's going to happen in the next week or so, and then also that you can, once I get those things review materials posted, I'll put that in the announcement too. Anyway, you guys, I'll see you later and have a great weekend. Bye.